ASF is a nonprofit organization developing and maintaining the separation between religion and state, advocating the scientific and humanistic viewpoint, and improving the lives of non-believers. You can learn more about ASF by picking up one of the flyers available at our back table or on the web at arfreethinkers.org, or the most reliable way, just getting to know one of the members that are here around you. Now, for our standard disclaimer. ASF is a diverse organization with members who represent a wide range of opinions. The speakers who present at our big meetings do not necessarily represent the views of ASF or its individual members. Because we are a 501c3 organization, ASF cannot directly support candidates for public office, but we can advocate for causes such as separation of church and state, scientific literacy, societal progress, and truthful communication. One of the key functions of ASF Freethinkers is to make friends and connections. So guys, I'm going to ask you, please turn to somebody next to you and introduce yourself to them. Thank you. Now, misinformation and pseudoscience are everywhere. Our misinformation of the day helps develop the critical thinking skills we need to exist in the modern world without being duped. Please give a round of applause to Vern Bradley, who will be presenting today's Skeptical Sidebar and Free Thought of the Day.
Thank you. All today comes from Mark Twain, who said, "It's not what you don't know that hurts you, it's what you absolutely know that just ain't so." In line with that, anyone want to guess who was the first person to successfully demonstrate radio telegraphy? Radio telegraphy. Okay, Marconi did radio telegraphy. I'm going to let you listen to radio telegraphy. Well, listen, in amateur radio, if I hit the key, a Morse code key, it doesn't send a beep over there. It doesn't send an audible beep. It sends a change in the signal. And then when the signal gets to your radio, it has a beat frequency oscillator that causes a noise. So whenever that change happens, your radio makes it sound like this. Waited for the whole thing there because that just said, at 35 words a minute Morse code, it said Arkansas Society of Free Thinkers. So I've got my text tone. My text tone has got my ham radio call sign on it. First system of radio signaling was described by Malin Loomis of Washington, D.C. in a paper dated 21 July 1866. That shocked me. I did not know this until about 4 days ago. He succeeded in, during October of that same year, October of 1866, this is a year after, 2 years after the end of the Civil War. And he successfully demonstrated conveying messages over a distance of 14 miles between Catochin Ridge and Bears Den in Loudoun County, Virginia. The experiment was witnessed by a United States Senator and a United States Congressman. Neither of them were terribly, I recognize their names, but they're not terribly famous. But he gave the following account of what happened. 2 mountain peaks of the Blue Ridge of Virginia, which are only about 2,000 feet above tidewater. 2 kites were lit up, one from each summit. These kites had a small piece of copper gauze about 15 inches squared attached to their other side and connected also with a wire of 600 feet length. The copper gauze is his antenna. The copper wire coming down was the lead. Today we'd use coaxial cable or twin line. If you had an old television, you'd use twin line. and the twin line was so ill insulated, you had to have standoff from the house and the pole to keep it from touching the pole and interfering with your signal. He then attached a galvanometer on each side. Galvanometers just show a radio signal, a electrical signal operating. Radio is electricity that just flies off the wire. The electricity coming out of the wall is 60 hertz, 60 cycles per second. The old KERN AM radio was 920,000 cycles per second. The buzz, KBEZ, the buzz, 103.7 is 103,700 cycles per second. That's when you get into that thing. That's when you get radio. That's when you, if you push that signal into an antenna, it will jump off of the wire and go. It doesn't go through the air. We know from having men on the moon and men in space, it just goes. It's its own force because it is part of the electromagnetic spectrum. But this man did this. He was granted the ability by the United States Congress to sell $2 million worth of stock in his company. But all of a sudden, we hit a bad time in the economy. He couldn't sell the stock. He continued to experiment till the day he died, but never had enough money to do much with it. And then, he died in 1886, and that's when Marconi came in, and using some of his knowledge and some other people who had experimented, made a commercially viable radio transmission of Morse code. And if you want to see early on demonstration of what it can do, there's a book called Thunderstruck. And this man writes on, Eric Larson's his name, he writes on 2 tracks, every book he writes. And the 2 tracks are this: there's a man who has taken a younger lover and murdered his wife and buried her in the cellar. And he dresses the younger woman like a boy and puts her on a ship. As all this is building up through the book, Marconi is coming to England to demonstrate his new telegraph. And it becomes viable enough at that point that they were doing ship-to-ship transmissions. So a message of watch out for the iceberg might go to this ship, then to the next ship, and the next ship, and the next ship. And all along this man and his young lover's journey out of England toward America, bulletins about him were being passed back and forth, and he had no idea. And it's a wonderful book called Thunderstruck by Eric Larson. And that, folks, is the Skeptical Sidebar for today.
Our big meeting offers you the chance to have your voice heard. Talk to us if you would like to deliver the free thought of the day, misinformation moment, or member story. You have something to share, and ASF is here to empower you. I'd like to thank our speaker today, Chris Barecki. Chris is the board president of Arkansas Society of Freethinkers, and he has been for quite a while now. Now, day to day, he is a professional manager with an MBA. His background is in education, social psychology, and I'm going to let him give the rest of that to tell you all about himself and our topic today. Thank you.
Thank you for that warm welcome. I will start off by saying I am utterly unqualified to give this presentation. I'm not a biologist. We reached out to a couple of biologists to celebrate Darwin Day. We weren't able to connect with any of them, so I decided I would step up and do a little research myself, check into some literature, and check out one of the most contentious topics in science today. And believe it or not, it's about Darwin's theory of evolution. So happy Darwin Day, everyone. Darwin's birthday was February 12th, 1809. Had he survived, he'd be 215 years old today. So evolution by natural selection is the paradigm of biology. It's not really a contested thing anymore in terms of competing with other theories like Lamarckian evolution, the idea that giraffes stretch their necks to reach higher branches and therefore their necks get longer, or the creationism is not really a scientific viewpoint anymore. But back in Darwin's day, all this was up in the air. First thing I want to appreciate about Darwin is just how far he went with how little he knew. So let's talk about what Darwin didn't know. 1859, Origin of Species comes out. What did Darwin not know? Well, Gregor Mendel did not come out with experiments in plant hybridization until 1866, and that was in a different language. It wasn't even widely known until about 1900. So Darwin is moving forward with his theory, which becomes the paradigm of biology, without any knowledge of Mendelian genetics. No idea of dominant and recessive genes, none of that stuff. 1850s to 1880s, so this time when he's writing The Origin of Species, people are just starting to accept germ theory as a possible reason why some diseases are caused by microorganisms. Prior to that, they were thinking that diseases were caused by miasmas, or basically bad smells from decaying matter. It would get into your body and cause it to decay too. 1869 to 1871, Friedrich Mischer isolates DNA. Just says there's this acid in the nucleus of cells. Doesn't know what it does. Who knows what it is? Just noted that there's an acid there. 1871, Darwin comes out with The Descent of Man and Selection in Relation to Sex. So, at this point, maybe had he possibly heard of Mendel, he could incorporate some thoughts there, but it wasn't until the 1880s and 1890s that scientists first observed chromosomes separating during cell division. And it wasn't until the 1890s to the 1940s, well into the 20th century, that we started to connect the idea that maybe these chromosomes had some sort of genetic heritability trait to them. Maybe that's where a mechanism, perhaps, for how traits go from parents to offspring. 1953, Watson, Crick, and Franklin finally identified the double helix structure and described DNA for the first time. And it wasn't until 72 that we sequenced the first gene in a bacteria. So think about what Darwin didn't know. He didn't have any of these subsequent discoveries. He basically had a theory without a specific mechanism of how it acts. If you asked him, okay, Darwin, with your theory of evolution by natural selection, how do you propose this occurs? How specifically does it occur? And he'd have to say something vague, or he'd have to just say, I don't know. He'd have to say, I don't have the specifics on the mechanism of how it works. I can just see it working this way. And that was the foundation that became the paradigm of biology today. And thinking about what he didn't know and what we know in hindsight is important to understand where he was coming from. Now, if you think that evolution by natural selection among serious scientists is settled science, a done debate, finished, it's been settled for a long time now. We all know how genetics work. We all know how inheritance works and how natural selection works. Think again, it's not so. Science is not a dogma. Science is a debate. It's a constant debate that's constantly going on. And there are problems out there for natural selection theory. For one thing, animals sometimes behave altruistically. They sometimes behave in a charitable way towards their fellow animals. Examples could be like feeding, protecting, guarding, alarming, moving, warming. Animals will do these things for each other, and the question is why. Any pro-social behavior like that is going to have a cost associated with it. It's going to use your time, your energy, your food. You're going to have to take risks of some sort. You're doing something that is a cost to you and is a benefit to somebody else. And so, in theory, as an altruist, if you're doing nice things for others, that puts you at a disadvantage in the game of spreading your genes as much as possible. And so the question is, how can pro-social behavior ever evolve in this survival of the fittest paradigm? I want to make this concrete, so I'm going to throw out some examples. Elephants, they're famously altruistic. This is a very pixelated image of an elephant helping a little elephant out of a ditch. Unrelated mothers, will help defend and protect young elephants. They'll help them out in situations like this. They also seem to form really tight social bonds, and they move as a herd in a group. The elephant mothers kind of co-parent a little, to use a term that humans use. But so raises a question. Why don't elephant mothers selfishly only help their own offspring? When I look at that elephant's knees, I think, ouch, that would hurt me. I mean, I'm not even an elephant. I don't even weigh that much. I weigh a lot, but not that much. So, why don't they just behave selfishly? Dolphins. Dolphins are known to help other dolphins swim when they're, sick or injured. They'll lift them up and help them breathe and help them nudge them along, They've been known to save each other from fishermen's nets and from attacks by sharks. Dolphins have been known to save other species. So completely unrelated to them, other species, they've saved drowning humans before. They've saved drowning dogs before. Why? How do you explain this by evolution? How does that behavior evolve? Dolphins have been observed defending humans, seals, and whales against shark or orca attacks. What would possess them to do that, put themselves in harm's way? And how does that gene that would allow them to do that not get eliminated from the gene pool? Here's an interesting photo. It was taken in 2009. It was witnessed by biologists Robert Pittman and John Durban, and they're in Antarctica. So this pod of orcas that you see in the background, one of them, was attacking this seal, and the seal hopped up on an ice floe. Eventually the orcas break up the ice floe, and that dumps the seal into the water. The seal immediately swims toward this group of humpback whales that were in the area right there that you see in the foreground. One of the whales rolls over on his back. I'm doing pantomime now, so y'all just... Whale rolls over on his back. The seal jumps up out of the water onto the whale's back, away from the orcas, and just rests there for a minute. And these biologists are like, what in the world is going on in the whole world of weirdness? I've never seen anything like this. And then the seal jumps off, when it gets a break and, moves on to the next ice floe. And that little interaction just, happens and ends in an instant like that. Why would a humpback whale help a seal avoid capture? This is one of at least 70 recorded episodes of humpbacks intervening in orca attacks on other species. It happens often enough that as little as we see of their lives out there in the ocean, we've recorded 70 instances of stuff like this happening. Weird, right? So here's an article in Science, and while you admire this magnificent creature, I'll read the abstract of this article. It said, we placed a free rat in an arena with a cage mate trapped in a restrainer. After several sessions, the free rat learned how to intentionally and quickly open the restrainer and free his cage mate. Rats did not open empty or object-containing restrainers. They freed cage mates even when social contact was prevented. When liberating a cage mate was pitted against chocolate contained within a second restrainer, rats opened both restrainers and typically shared the chocolate. So thus, rats behave prosocially in response to a conspecific's distress, providing strong evidence for biological roots of empathically motivated helping behavior. So the question is, are you better than a rat? Would you help somebody out? We've got the experiment set up right here. Byrne brought some chocolate in the back. If anybody wants some, you can get some and bring some to the person next to you. No, I'm kidding. Anyway, this is really interesting that you can do this experiment with rats, and rats will help a fellow rat out and then share the food with them rather than just going straight to the food and getting more chocolate. It seems counterintuitive, right? How does that evolve? How does this world of selfishness and survival of the fittest described by evolution describe these behaviors? Vampire bats. This is an illustration, not a photograph, obviously, but they share food. A vampire bat will die if it does not eat in 3 days. It'll starve to death. It gets progressively weaker, it'll starve. So these bats are in constant peril. They fly around, they look for a donkey or cattle or a camper or somebody to bite into and, you know, suck some blood out of. And they don't always succeed. So, and also sometimes they get sick and they can't fly. They get lethargic. This sharing behavior, where one of them will regurgitate blood into the other one, is most frequently seen among bats who are related or who have shared food in the past. And they tend to build a relationship, even among strangers. You know, complete unrelated bats can build this relationship. They're licking and grooming each other, and then that kind of escalates to eventually becoming food-sharing partners. So this outcome of going 3 days without being able to find food, that happens often enough. A lot of bats in a colony would probably die if left to their own devices. They would just hit that, you know, unlucky sequence of events and be unable to feed for 3 days, and it's curtains. And so this situation where they're able to share food creates this reciprocal relationship where I'm going to share food with you because that means you're going to be around in 3 days when I haven't eaten, and you're going to share food with me, and we're going to keep each other alive together. And turns out that has somehow evolved to become the strategy among vampire bats. This little fishy, I'll try to pronounce it, Harpagopher bispinus. It's a little, called a Magellan plunderfish, lives down in Antarctica. Egg incubation for this fish is the longest in the fish world, right? It's 4 to 5 months that somebody's got to guard these eggs in a nest. So as usual, the mom creates the nest, lays the egg, spawns, and all that kind of stuff. And then she guards the nest. But interesting thing happens if the mom disappears for whatever reason, and an unrelated male comes across the nest. The unrelated male will adopt that nest and guard it. Not his kids, not his eggs. Unrelated male will guard it. Then if something happens to that unrelated male who's guarding the nest, another unrelated male can come in and guard it. And in that way, the 4 to 5 months passes in the treacherous world of fish, and there's always somebody guarding the nest. How does this happen? These unrelated individuals, they're not promoting their own, you know, well-being by doing this. So, and they're not reproducing by doing this. That's somebody else's reproduction they're facilitating. It's an issue. Another reciprocal issue is when, you know, primates do grooming of each other. They're both increasing their evolutionary fitness here by becoming more free of parasites. They're getting the parasites picked off of them, and then they return the favor and, you know, keep that relationship going. It's an open question, though. At one point, does a relationship become close enough that you say it's not just a trade, it's a relationship? Like, it's genuine caring, it's genuine charity and altruism. We're going to get back to the questions about how we define these things, because I think that's a big deal in this debate. Songbird. Here's a very pixelated songbird sounding the alarm because there's a cat stalking around and the other birds don't see it yet. Why would this songbird sound the alarm? It's a very common thing. Different animals do it, ground squirrels and whatnot. Why would this animal sound an alarm? It gives up its position. You know, now the predators know where you are. If there's a predator you don't see, now that predator is alerted to your presence, might be sneaking up right behind you. You've just wasted time. Maybe the proper thing to do when you see a cat or a bird of prey or something like that is to quietly escape. That's, you know, seems logical, but instead they sound the alarm, and they're notifying their competitors for food, they're notifying their competitors for mates, they're notifying other species that there's a predator around. How does that help this individual? How does that perpetuate this gene that causes them to sound the alarm? Chimpanzees in Leipzig Zoo in Germany, they're trying to play a sharing game, and the headline here says it all. They showed that they would return a favor at a personal cost. Now, here's the setup. I'm going to have to explain this a little bit because it's not intuitively obvious, so don't feel bad. It's not at all clear. Okay, so the partner over here has 2 ropes. They can pull rope A and pull a tray with a banana treat toward them, or they can pull rope D, which unlatches the gate, which allows the subject over here to reach their hand in and the subject can either pull rope B or C. B brings them a banana treat. If they pull C, it kind of pulls apart and gives a banana treat to themselves and to the partner. So this, like many psychology experiments, is rigged. The partner is actually a confederate of the experimenters. And no, it's not a human in a chimpanzee costume. They actually trained a chimpanzee so that chimp that's the partner role will only pull rope D. They'll only ever pull rope D. But the subject over here is watching, and they watch the partner give up the opportunity to pull rope A, and they're instead pulling rope D and giving them the option to choose. So then the partner makes their choice, and they can either get their reward with B, or they can, give both animals a reward by pulling C. Any questions so far? That's a complicated experiment. It really is hard to explain. But yeah, basically, partner moves first. Partner chooses D to give subject the choice to either get, a selfish reward or to share a reward. 77% of the time, when the proportion sizes were equal and there's nothing to lose, 77% of the time, the subject is going to pull C and reward the partner and themselves. So there's a much greater than chance odds that they're going to say, well, thank you for that. You gave me a chance to have a treat, and you risked there's a risk to you because I might have pulled B and you would have gotten nothing. So, but 77% of the time, something happened where they pulled C, causing both of them to get a reward. So then the experimenters did experiment number 2. They said, what if we put more food on the B plate, more treats on the B plate, so that if you behave selfishly, if you just pull the B toward yourself, you get more than if you share and pull C. Well, that had an effect. Only 44% pulled C at that point. But still, 44% of chimpanzees were willing to suffer a personal cost, having less treats, in order to reward the partner for giving them the opportunity to have a treat. So this is the kind of thing that we keep finding. There's loads of these sorts of studies out there, and research in this field is hot right now. There's more stuff coming out, every month. But I just wanted to give you an example, and the idea is that chimps are willing to pay a price to help other chimps that have been altruistic toward them in the past. Now, changing subjects, no discussion of this kind of ethics and altruism would be complete without a little game theory. This is the prisoner's dilemma, and it looks like a really simple little game. I assure you it is not. There have been thousands, literally thousands of scholarly research articles written about this little game since it was invented. And it's a metaphor for how ethics and altruism could possibly exist in the world. And it keeps coming up. I say it's a metaphor because you can apply it to different things. You can apply it to business. You can apply it to cheating on your partner. You can apply it to warfare or keeping your terms of the treaty. Used car sales, whatever it is, it can be applied here. And so I'll just read the original language describing this paradigm to you. 2 members of a criminal gang are arrested and imprisoned. Each prisoner is in solitary confinement with no means of speaking to or exchanging any information with the other. The police admit they don't have enough evidence to convict the pair on the principal charge. They plan to sentence both to a year in prison on a lesser charge. Simultaneously, the police offer each prisoner a Faustian bargain. If he testifies against his partner, he will go free, while the partner will get 3 years in prison on the main charge. But there's a catch. If both prisoners testify against each other, both will be sentenced to 2 years in jail. The prisoners are given a little time to think this over, but in no case may either learn what the other has decided before they make their own irrevocable decision. Each prisoner is concerned only with his own welfare, with minimizing his own prison sentence. So, what do you choose in a game like this? What do you do as a prisoner? And here's the issue with this. There's something called a Nash equilibrium here, where the best thing to do, regardless of what your partner does, is to betray them. to testify. So look at the payouts here. If you testify and your partner stays silent like a good person, then you run scot-free and they get 3 years. That is a better alternative than you would have gotten if you had also stayed silent like they were. Moving over to the right column, if you testify, you get 2 years if they testify, but that's better than 3 years if you had not testified. So in either way you go, you're better off testifying against them. But look at what we're giving up. If we could just get along, if we could just cooperate with each other, you get a 1-year sentence each. The sum of those sentences is 2 years. Instead, we're accepting twice worse outcome because we can't trust the other. So that's, in a nutshell, one explanation for evil, right? One explanation for why we don't live in a Star Trek world of cooperation and everybody's looking out for everybody else. And it's just the math doesn't work out sometimes. The outcomes don't work out sometimes. And again, you can play this game in a number of different paradigms. You can be a smuggler and you're going to exchange suitcases with somebody. You're going to exchange jewels for cash, for example. Well, you're tempted to leave your suitcase empty and just hand them the empty suitcase and take off with the cash. But wait, they're tempted to leave their suitcase empty and give you an empty suitcase in exchange for your jewels. And so what happens is you end up exchanging empty suitcases, right? Nothing, no good comes from that. Arms treaty, this kind of comes up. Think about the United States and Iran. You know, we had a nuclear arms treaty at one point with Iran, and Iran has to decide, am I going to secretly continue developing weapons, or am I going to continue to cooperate with the treaty? If I continue to cooperate with the treaty and the United States turns hostile to me, I will be without weapons, without nuclear weapons. And that's a worse position to be in. So again, it's kind of a theory of everything in game theory. So like I said, in a one-time interaction, defection is the optimal strategy. It leads to the highest outcome regardless of your opponent's actions. However, what happens if we do a tournament? What happens if there's 1,000 of these and your point is to try to amass the largest number of points possible, for example, or the lowest cumulative jail sentences possible? They did a study or an experiment back in the early 1980s when computers first came out, where they said, hey, all you scientists working on game theory, submit to me a simple algorithm that we can write into the software to play the prisoner's dilemma. And all these different algorithms are going to play against each other in just this giant mosh pit of games. And we're going to see which theory comes out with the most points. We're going to see which one is the best theory, the best strategy to play. And what happened was somebody submitted an algorithm called tit for tat. Tit for tat is, I'm going to start off cooperating with you. I'm going to start off being kind. And from then afterwards, I'm going to do whatever you do on the previous move. Okay? And this strategy won the game, won the tournament. And it's kind of counterintuitive. Why? So other strategies that you could have submitted were like always be selfish, always be altruistic, for example, maybe never forgive, have a no forgiveness strategy. Whatever the other player does on the first round, you continue whatever pattern they went on forever. But tit for tat won because if it runs up against an always cooperate strategy, what happens? Always cooperate says cooperate, tit for tat says cooperate because it's the first move. And then on the second move, tit for tat says cooperate because the other player played cooperate on the last move. Other player continues to play cooperate. It just continues forever, cooperate on both sides. And they maximize points, and they both get the same high score. If tit for tat runs into a always be selfish algorithm, then tit for tat plays nice on the first round, always be selfish, screws them over. Then tit for tat comes back and says, okay, I'm not going to cooperate with you, and from then on they don't cooperate forever. It continues that pattern forever. So tit for tat loses a point in that first round against always be selfish. But in the context of the tournament, when it's playing against other strategies, tit for tat comes out on top because of the points it accrues playing against other strategies. And some of these were complicated. Some of them were like, do it in this pattern, like, cooperate, defect, whatever. tit for tat would just roll with those punches. It would return punishment, to anybody that defected against it, but it would also cooperate with anyone that was willing to cooperate. So here we have a situation where it depends on your paradigm. Are you playing one round or are you playing to infinity? I would say that those vampire bats in the cave or in the hollow tree, they're playing a multiple round game, right? So that's maybe the story of how they learned to cooperate, because that's how you end up not being so dead anymore. All right, on to my point. Now that you've got some background information, here is the war, and here is on who's each side. This is the war in biology. And you'll notice some of these names are some of the most famous names in the business. On the gene-centered side, you've got celebrities like Richard Dawkins, Daniel Dennett, David Haig. You've got some really heavy hitters over there, people you've heard of. On the group selection side, you've got Stephen Jay Gould, David Sloan Wilson, E.O. Wilson, Conrad Lorenz. This is a battle of the heavyweights. So this is not some kooky theory that a couple of people have, that a couple of biologists that isn't really accepted by the mainstream. This is a heavyweight battle royale in the land of theory, I guess. So what are these things that we're talking about? First, I'm going to tell you about what provoked this conflict. The gene-centered view arose in opposition to some really causal group selection explanations that had risen in the previous decades. Dobzhansky, 1937, claimed that species maintain their genetic diversity of their population in order to cope with unforeseen environmental changes, like investors investing in a diversified portfolio. Well, I don't know if that passes the critical thinking test, right? These little animals are supposed to be thinking like investors. They're thinking about, like, do we have enough genetic diversity in the room? I don't know. Should I not eat because we're not genetically diversified enough? Maybe I shouldn't breed. There's a lot of me around. This doesn't sound right. Ali, 1951. Dominance hierarchies exist to minimize within-group conflict so the entire group can be more productive. Well, that's awfully charitable, but what would prevent a selfish individual from coming into that group and getting all the benefits and giving nothing in return? Shouldn't that be the trait that's selected for? This is the big one. Wynne Edwards, 1962, claimed that individuals constrain themselves from consuming food and reproducing so that the entire population doesn't crash. Well, we know that entire populations do crash, actually. You know, the old rabbit population, they go up and down, so empirically it doesn't check out. But again, we're starting to anthropomorphize here and give these animals values and plans, and like they're doing these things, as Conrad Lorenz said, for the good of the species. Who knew that little fish in the water and birds and things like that, they have this idea in their mind that we've got to all work together for the good of the species, and I'm willing to die for the good of the species, or whatever. It just kind of, it's starting to get sloppy here, right? We're getting theoretically sloppy, and the backlash to this was probably well-deserved, but this is how it plays out. So here's my summary of the gene-centered view of natural selection. This is the one side with Dawkins and Dennett and Haig. Adaptive evolution occurs through different reproduction rates of competing genes. Genes cause traits which lead to differences in survival and reproduction. Thus, traits are passed from generation to generation almost exclusively by genes. The only reason they say almost is we were thinking about things like viruses and injecting genes and stuff like that. Okay, fine, we'll accept that. But natural selection is genes. That's it. Individuals are simply vehicles for genes. The struggle and evolution is with genes, and we are just their carriers. Okay? Is there anything in this that contradicts what you learned in high school biology? Probably not. That's because the people who wrote your high school biology textbook were gene-centered theorists. But really, it's hard to disagree with a lot here if you know anything about natural selection. Compare that to the multi-level view. In addition to genes, competition and selection operate at other levels, including groups. Groups with more altruistic members may create more offspring than groups with fewer altruistic members. thus spreading the genes for altruistic behavior. You may think that's far-fetched. You may think it's unlikely, but let me show you the math. All right, y'all. Let's do a big stretch and get our brains warmed up. We can write equations to describe the fitness of altruists, or we can write equations to solve for the fitness of selfish individuals. I will break this down for you. X is the number of offspring that animal would have, that the average animal in that group would have, in the absence of any altruistic behavior. That's our baseline. C is the cost, in terms of offspring, of altruistic behavior. Note that C only appears as a subtraction in the fitness of the altruist equation. B is the benefit in terms of offspring to the recipient of the altruistic behavior. NP means the number of altruistic individuals, and it's for the altruistic, you see, it's NP minus 1 because they are one of the altruistic individuals and they can't give themselves benefit if they need the benefit. So that's where the N minus 1 comes in. And so the benefit is based on the percentage of altruists in the group, essentially. Number of altruists minus 1 over the group minus 1. All right, so if the selfish individual doesn't have any of those, subtractions, right? They don't pay a cost. They don't have C in their equation. And the NP right here does not have a minus 1 because they get to take advantage of the generosity of all the altruists in the group. They are not one of them. They are not subtracted from that group. Okay, so already, how do you possibly make the fitness of the altruist ever be higher than the fitness of the selfish individual if you have the same numbers in all those variables? You can't. I mean, you'd have to work with negative C or something. So is this on its face proof that altruism is not a natural selection kind of thing? It's it's something else. It's impossible for altruism to evolve. What do y'all think? Poll? Anybody so far? Impossible?
Strong opinions on the matter.
Okay. Hold them real quick, though.
Your equations up here are in fact a sort of discretized version of something called the Price equation
Yes.
by George Price. It was formulated in the early 70s. It is, in a certain sense, a direct description of what evolution is. You take the ordinary definition of evolution as change in gene frequencies over generations.
Mm-hmm.
Price's equation describes that. It is a little more complicated than this. It is a stochastic partial differential equation.
Yeah.
And it predicts really well altruistic behavior. And in fact, your grouping that you had up there of, well, here's the people on the gene selection side, and here's the people on the group selection side, was really unbalanced because the overwhelming majority of biologists believe in gene selection, not group selection.
Yeah.
They rejected group selection back in the 1960s when John Maynard Smith, W.B. Hamilton, George Williams, and Richard Dawkins, the four of them basically formulated the gene selection version, and then Price came along with a beautiful description that is very predictive.
Almost got into Price.
It makes predictions from directly measurable things,
Mm-hmm.
and it overwhelmingly predicts correctly.
Yeah, so I was about to get into, I almost got into Price, but I had to set some boundary on how deep into the weeds I'm going to go on this presentation. However, you are correct that group selection was rejected by mainstream biology in the 60s and 70s. And then all their students were taught to reject it as well. If you went to high school or to college or got a textbook Chances are it was written by someone who has a gene-centered view of evolution. If you are a multi-level selectionist and you go into a job interview trying to get in at a university somewhere, you will probably be asked about this, and you probably won't get the job if you're a multi-level selection theorist. But let me get into the case being made by the multi-level selection theorists real quick and see how that goes. The reason this is kind of bowed is because I maximize my own evolutionary fitness by not hand copying this. This is straight from, where did I have it? This is straight from Sober and Wilson's book, Unto Others, and it describes kind of a two-group application of this fitness equation, right? So let's say that we have two groups, 100 individuals each, n equals 100 in each of those. P is the percentage of altruists in the group, and in group 1 it's 20%, in group 2 it's 80%, just going top to bottom here. There's your fitness for the altruist equation with some numbers plugged in there, and the fitness for the selfish individual. They're losing one offspring in exchange for providing a benefit of 5 to someone else. And you can see the numbers are plugged in there. The 99s are the n minus 1, right? And the 19 is there because there's 20 altruists, n minus 1 is 19, so on and so forth. So we can come up with the fitness of the altruist and the fitness of the selfish individual. And you see in group 1, we can already calculate 9.96 offspring for the altruistic individual, and in group 1, 11.01 offspring for the selfish individual. Group 2, the altruists do a little better. They've got a 12.99 offspring, but the selfish individual's got a 14.04. Kind of looks like the outcome of the prisoner's dilemma, doesn't it? Where being the selfish one gets you a higher percentage, higher fitness in either case. When we run one generation, now our N is 1,080 for group 1, and in group 2 it's 1,320. So group 2 grew a lot faster than group 1, mainly due to the help of all those altruists, right? That 80% of them are helping, and so that cranks up that benefit and how much it's applied to each individual. So we got 1,320. We've got hundreds more individuals in group 2 now than we have in group 1. And however, look what happened. The percentage, that P tilde thing, of altruists has dropped in group 1 from 20% down to 18.4%. In group 2, it dropped from 80% down to 78.7%. So the altruists are dying out, right? The altruists are becoming less frequent, right? Everybody looks very depressed by this. I don't know. But this is an illustration of something called Simpson's paradox. Look at what's happening with the global population. We start out with 100 plus 100 equals 200 individuals as our starting point. Half of those individuals were altruists. Now we have 2,400 individuals, and 51.6% are altruists. How did that happen? How did they get less relatively frequent within their groups, but as a population they became more frequent? And this is, do the math, criticize the equations if you want, but this is the idea of how a altruistic behavior could arise in a population. It's also maybe a theory of why it doesn't always arise, because you can tinker with that benefit number, you can tinker with the size of the groups or whatever, and you could, or the distribution of the altruistic gene, if there was one, and you could get different results for this. So maybe it emerges in some behavioral contexts, but not others. But yeah, this is the model for how you get from 50% altruists to 51.6%, even though the selfish ones are gaining ground within each group. So this is direct from Sloan and Wilson. Because group 2 grew much faster than group 1, the overall percentage that's what made it get bigger. For those of you who are more visual learners, who are kind of glazing over like I did a lot of these, here's another excellent snapshot from the book. that I did not have to hand create myself. This is not to scale, but it shows that, you know, the piece of the pie, the darker is the altruists, and the lighter is the selfish. And as the overall pie grows so much bigger when you've got altruists helping each other out and boosting the reproduction rate, that you get more altruists in the end. And that's the visual display of what we just saw there. However, we got some limitations here. This is assuming like an asexually reproducing organism. They aren't interacting. We're not talking about Mendelian genetics here, where maybe altruism is recessive or dominant. We're not talking about any of that. We're just saying if the group does this and the reproduction numbers turn out this way, it's very abstract. It's very high level, right? Hamilton, as you mentioned, W.D. Hamilton talked about, well, maybe kin selection has an effect in the real world. You know, we can do this desktop discussion, but I'm thinking kin selection has an effect in the real world, he said. And he said, a gene for altruistic behavior will spread when the cost to the individual doing the behavior is less than the benefit to the person or the animal you're helping times their degree of relatedness to you. Okay? And in this model, you know, the gene could spread. He's saying it could spread, but this is still a gene-centered view. This is still a selfish gene kind of perspective that allows for some evolution of altruistic behavior. And so this is, in a sense, you know, work that tries to save the gene-centered viewpoint from the evidence of altruistic behavior by saying, look, we can still explain it within the gene-centered paradigm. So what is the degree of relatedness, that R in that equation? So if you have a twin, then they share 100% of your genes with you. If you have a parent or a sibling, you know, 50%, half sibling 25, grandparent, grandchild 25. So these numbers should reflect in evolution terms or the ability of a gene to evolve that has altruistic components to it. It also leads to jokes about, like, I would gladly sacrifice my life to save 2 brothers, 4 nieces, or 8 cousins. Because that's what it would take to add up to the value of my life and my genes. And so a big question with this is, you know, can organisms really recognize their kin in the middle of an altruism decision? We've got examples from, you know, like the vampire bats, for example, where unrelated individuals, examples from the whales and the dolphins where, you know, unrelated species are helping each other out. And are organisms really able to make that call and say, well, I could sound the alarm about that cat that's about to pounce on this other bird, but I'm thinking that other bird is like a 4th cousin. I just don't think it's worth it. I think I'm going to fly away. It's kind of, you're at risk again, just like the sloppy thinkers about group selection had been doing. You're at risk of thinking that the animals are having this thought process in their mind. And a group, in fairness, a kin selection theorist would say, no, I'm not proposing that they have this big calculation going on in their mind, doing the Hamilton equation or something about, we're not saying that, we're saying, will a gene to just help evolve? That's all we're saying. So I think that's reasonable. I think it probably would evolve. So you see scenes like this, where a hornet has attacked a honeybee nest, or honeybee hive, and the honeybees, they're much smaller than the hornet. They're attacking the hornet. They're piling up on it. And that hornet has jaws that can just decapitate them one at a time. And it's got a stinger that's just ferocious. And these little honeybees, they're sacrificing their lives for the good of the hive. But there's a case to be made of what else are they going to do? These are worker bees. These are not reproductive members. Their genes can only perpetuate into the next generation if the queen survives. So if one of these bees decides, you know what, that hornet looks scary as hell, and I'm just not going to mess with it today. I'm going to stand back and be selfish, let all the other bees take care of it. Well, that bee would not enjoy any evolutionary benefit from doing that because it's not going to reproduce. It's not reproducing anyway. In fact, it would suffer less evolutionary benefit because if those bees fail and there's more hornets and they all get, we just needed one more bee to beat the hornets, then the queen gets eaten, all the eggs get eaten, and some of those eggs might be queens that could have reproduced the genes into the next generation. Selfishness is not going to evolve in this situation. Ants are the same way. Ants will behave a lot like this. So it's the whole hive or the whole nest that can be seen as a cooperative whole, or almost like a whole organism. Like these are almost like cells in the organism. We sacrifice cells of our body every day so that so that the whole can live. And these bees don't have any evolutionary value in and of themselves as vehicles for the genes. The queen does. So we can sacrifice these if the need comes up. Yeah.
Well, but do the drones, they have the genetic, it's already in their genes that this is what they do, right?
You'll not find a drone in this battle probably because they're just the males that are.
My point is that the worker bee, whatever it was
Yeah.
you were referring to, their job is already in their genes, right?
Yeah. So when you.
So is there any consideration of any altruistic factors in there at all?
Yeah, that's an excellent question. If these animals are just behaving according to instinct that has been, programmed into them by their genes, is that really the same thing as the rat freeing the other rat and then sharing the chocolate with them? We're into really sketchy theoretical ground when we go there. And we're in really sketchy theoretical ground when we say that these bees are being nice, in a sense, or cooperative, when they're kind of like biological robots. They're at that level of simplicity, a few thousand neurons really running these things. So it's kind of a matter of, what do you see here? What do you see when you see this picture? Do you see a selfless act of altruism, or do you see kin selection? And maybe it's like a Rorschach test where what you see tells more about yourself than it does about the actual picture of what's going on in nature. So selfishness beats altruism within groups, but altruistic groups beat selfish groups, is the quote by, this is an advocate of multi-level selection. And they can prove that on paper. They can prove that the group that has more altruists will survive better. And then you get into the idea of, well, what if the group can discriminate against the selfish members of its group? What if we can banish them and increase the percentage of altruists in our group? Well, then you've got something that could really take off. You've got a population that could, form groups that would, exclude selfish ones. You've got, on the other side, you've got kin selection. There was an old theory that was around, that came up, or an old metaphor, I guess, about if there was a gene for men to grow green beards, and other men with green beards could treat their fellow green beard holders favorably, then the gene for green beards would perpetuate faster because of that differential treatment. And so the question is, under what circumstances can altruism evolve? It has something to do with being able to distinguish the altruist from the non-altruist, being able to do something about that. And, we got some constraints in our model now that may or may not work out. So, I will conclude today by asking, what did Darwin think about this? We started off talking about Darwin. Did Darwin have any thoughts about this? And this is kind of small, so I'll read it to you. Darwin was a multi-level selectionist. This difficulty, though appearing insuperable, is lessened, or I believe disappears, when it is remembered that selection may be applied to the family as well as to the individual, and may thus gain the desired end. Breeders of cattle wish the flesh and fat to be well marbled together. An animal thus characterized has been slaughtered, but the breeder has gone with confidence to the same stock and succeeded. So if you slaughter a cow and think, this is top quality meat, chances are their relatives have top quality meat as well. He's talking artificial selection here, but this was from The Origin of Species in 1859. Darwin goes further in The Descent of Man. It must not be forgotten that although a high standard for morality gives but a slight or no advantage to each individual man and his children over the other men of the same tribe, yet that an increase in the number of well-endowed men and advancement in the standard of morality will certainly give an immense advantage to one tribe over another. A tribe including many members who, from possessing in a high degree of the spirit of patriotism, fidelity, obedience, courage, and sympathy, were always ready to aid one another and to sacrifice themselves for the common good, would be victorious over most tribes, and this would be natural selection. Also from The Descent of Man, if one man in a tribe invented a new snare or weapon, the tribe would increase in number, spread and supplant other tribes. If the tribe thus rendered more numerous, there would always be a rather better chance of the birth of other superior and inventive members. So Darwin was a multi-level selectionist. He believed in the group selection. And this is without any knowledge of genetics. Genetics came later. And the gene-centered view of evolution came later, much later. 60s, 70s is when that started. And so in this light, the theory of evolution started out with group selection, had it cut out, and now people are trying to squeeze it back in. So we've got some real questions to think about in terms of where the science is going to go. I hope I've given an even-handed presentation of both sides of this debate. Not being a biologist myself, I don't really think I know enough to pick a side in this war. I think there's valid points made on both sides. But yeah, so what is our definition of genuine altruism as opposed to kin selection or weird little artifact behaviors that might have happened once or twice, or you sometimes get genetic baggage when you inherit something. For example, when they tried to turn foxes into tame dogs in Russia, they bred thousands of foxes, artificially selected the most tame foxes, generation after generation. And you know what they came up with at the end of that? A dog. They reinvented the dog. These things had like spots on their fur, and they would do weird dog things and behaviors. They didn't behave like foxes. They reinvented the dog. And they're like, we thought we were going to be able to have pet foxes. It turns out the tameness genes have something to do with the other behaviors, the code, the look, everything else. So this altruism, how do you tell the difference here? If evolution occurs at the gene level and at the group level, could it also be occurring at other levels, such as cultures? Do some cultures supplant other cultures, like Darwin mentioned? Darwin was, while he was writing that, witnessing the eradication of Native Americans by Europeans. So, maybe there's some of that coloring his statements. Should we resort to group selection explanations only when gene-centered explanations seem to fail? And is that intellectually honest to have this pecking order of, okay, we'll always call a behavior genetically determined unless we can't explain it, and then we'll fall back on this, group selection theory. I don't know if that's a good philosophy of science right there, because you've just put them in pecking order based on what, and also you've created this kind of catch-all where anything not explained by our main theory, we'll just throw it into this other theory and not challenge the main theory. So that's a question for people interested in philosophy of science. And if groups are necessary to explain altruism, then does it follow that we should orient our society toward the formation of groups and, making sure that our prisoner's dilemma interactions with each other are repeated, like repeat customer type of situations rather than one-time exchanges? That's kind of the normative question that deserves to be asked, I think. And so, as a non-biologist, I probably can't answer your detailed technical questions, but we can open it up for discussion if anybody would like to throw their 2 cents in on this war. Jim?
A philosophical argument from someone who only passed the few 6 hours of biology because of the altruism of a professor. We have 2 things here that we've talked about, this kind of altruism versus selfishness, but is there not possibly a third element? That bird seeing the cat and tweeting to warn the other birds, maybe it likes the other birds and wants to pet them, maybe it hates cats.
I thought of that, you know. Maybe what the dolphins are doing is not saving the swimmer or the seal. Maybe the dolphins are trying to hurt a predator that eats their offspring. So the fewer predators that exist, the better off the dolphins. There was a book written in like '74 by one of the early gene-centered view folks who said, "Scratch an altruist and watch a hypocrite bleed." And that kind of summarizes the extremity of this debate. It's that, you know, if you're looking for an altruistic explanation, you just haven't looked hard enough for the gene-centered explanation.
There's a couple things that haven't come in here. One of them has been known for a long time and should be part of a presentation like this, and that is Dawkins' ideas of an extended phenotype. Genes produce proteins that act out in the real world in various ways, but not necessarily just for one purpose. And in fact, genes can affect the behavior of an organism that they aren't even part of. And that idea of an extended phenotype, of a gene being able to influence things outside where you might at first only expect it to, is one of the core ideas of gene selection theory.
Yeah.
The other one is one that I've been reading evolutionary theory for 70 years, and followed it pretty closely for a long time. Recently, I haven't been able to, just because I haven't been able to get physical access to a research library, but one of the popular books that I just finished here recently, I think has the most important idea in evolutionary theory since Darwin, and that's horizontal gene transfer, where, in effect, this is absolutely necessary to understand anything about bacteria or archaea, which their primary source of variation that selection would act on is not the genes that parents pass to children, because in bacteria and archaea, that's purely by fission. And so the children only get an exact copy, or pretty close to it anyway. Whereas by horizontal gene transfer, they pass genes between what we might call different species. There is no real concept of species at the level of bacteria.
Yeah.
The really surprising part turns out to be, it's not just bacteria. Humans I've
Yeah.
never seen anything written connecting that to the evolutionary theory. I've never seen anything like, say, a modified version of Price's equation that includes horizontal gene transfer. Because Price's equation is purely vertical gene transfer. It's parent to child, and absolutely nothing else. Whereas we now know that's just not true. We can look at the real world and say, humans have thousands, actually, if you count things like gut bacteria, millions of genes that don't come from the human genome.
Yeah, if you'll notice, at some point in this talk, I switched from talking about group selection theory to multi-level selection theory.
You know,
And a lot of that is because of things like you're describing, horizontal gene transfer. People back in the 60s and 70s were unaware of epigenetics.
well, I mean, it was
They were
known,
unaware
but it
of-
wasn't known the degree to which it permeated
Yeah.
all of evolution.
I mean, let's talk about your microbiome in your body. You can have genes for great health, but if your microbiome is messed up, you're not going to be healthy. So if you,
In
the
any
problem with the
meaning-
gene-centered
in any
view,
meaningful sense, it's part of you.
yeah, and
You
so
as an organism include that microbiome.
yeah, so if that's actually a problem for the gene-centered view, because if you scan this person's genes and you're like, well, the genes check out, this person's fine, and they're actually sick as a dog, it's because you're ignoring a lot of genes that are going on in their gut that aren't theirs. They're the bacteria's genes that are causing that to happen. And so one of the problems for the neat equations that were put together in the 60s and 70s to explain the gene-centered view is that the statistical noise is just increasing as we find out more and more and more and more, and these equations are starting to look like oversimplifications because you've got your microbiome, you've got horizontal gene transfer, you've got viruses and stuff putting genes into you, you've got all sorts of weird effects, and then you've got a lot of studies on genetics were done, with offspring, and they would assume that this offspring starts at a clean slate the day they're born. Like this rat pup will be, they're a clean slate from the day they're born. They're just like any other rat would be. Well, actually, no, because the prenatal environment determines a whole lot about your traits and outcomes. If you take a mother rat and she's pregnant and you stress her out, the mother rat produces more stress hormones. The fetuses, or feti, absorb more stress hormones. The absorption of those stress hormones causes the fetuses, it actually inhibits the development of a neural system that reduces glucocorticosteroids, and I may be wrong about that. But whatever the stress hormone is, those babies are then born with less of an ability to handle stress and stress hormones. What happens when those babies go and get pregnant? Well, they are not as able to handle stress hormones. Their fetuses are based in this environment of stress hormones. Their fetuses, the grandchildren now, have the same trait of not being able to handle stress it's gone on for generations. And that kind of effect, they found it reduces over time, but it's still transmitted from the mother to the fetus by the prenatal environment, not their genes, not any other change to the genetics, but it's a huge trait difference that comes out based on your prenatal exposures. They've done this with human infants. They had people read The Cat in the Hat, or they'd have people read a series of nonsense words designed to match the tone and rhythm and everything else of The Cat in the Hat. And when these children were born later, the kids preferred, The Cat in the Hat a lot more so if they had been read that story while they're prenatally, because they can hear it. And it's like, how do you model that mathematically? The world is so complex, and we're just peeling the onion back and finding more complexity. And I think biology is going through a moment kind of like economics is going through, where we had this quantitative point where theory and equations were expected to explain everything in the 60s and 70s at about the same time. And there's a lot of cross-pollination at the university level, economics and biology, people looking to figure out behavior. Psychologists were talking to economists, and they were talking to biologists to try and get their perspectives. And so a lot of this stuff synthesizes into, we're going to have equations to talk about how traits get passed down. We're going to have kinship selection equations, we're going to have fitness equations, price equation, and as time went on and we discovered all these other influences on people's traits, it just gets more and more unwieldy. You have to keep adding factors to the equations.
This is science.
Yeah.
One of the beauties of formulating it mathematically is it's falsifiable. You can say, okay, I can measure this term and this term and this term, and I predict that if I go out and do an experiment, here should be the outcome. Here is what the change in alleles from one generation to the next should be. And turns
Yeah.
out, oh, I'm wrong. That's when you have to go back and modify your equations. And this is done in every science. And
It's a good thing.
biology is no different. Having vague, fuzzy words doesn't make your predictions better, it makes them worse.
This may be another element of the Rorschach test because let's say that we go back to, let's say we go back to these equations of fitness, and we don't like fuzzy concepts, but what do we have here? We have fuzzy variables. B, we can just define B. How does that relate to an organism in a complex world behaving a certain way or not? Sometimes it gets eaten, sometimes it doesn't. Have we really calculated cost correctly? When we say a bird has a cost for chirping, how high is that cost? Can we calculate it as humans? Do we know better than the bird? I don't know.
We can go out and measure it in the real world.
Yeah.
We can study bird populations and say, birds that chirp get eaten this often.
Yeah.
And birds that don't get eaten this often. So yeah, it is measurable.
Yeah, it's tricky though. And a lot of, some of the problem is that it's easy to do a desktop exercise and say, okay, I'm going to make an equation, I'm going to assume some values for these variables, and look how it turns out. If that doesn't reflect what's going on in the real world though, then you're actually worse off than if you were relating fuzzy concepts together in a social sciences way. If you were using constructs, because if you say that the cost of the bird chirping is that's got to be at least half an offspring, right? Well, if you're off on that by an order of magnitude, then your math is only serving to give yourself a false sense of confidence.
And that's the time you say, well, I guess those equations are wrong, I gotta do something else.
Yeah, so you can add more factors.
This equation, or these equations right here, for example, are really just really crudified versions of Price's equation.
Yeah, they're kind of more talking points than something that would be applied actually.
For one thing, these are not time dependent.
Right. Yeah, it's like a
Price's equation is a partial differential equation.
yeah.
Very much time dependent.
So yeah, it's a trade-off between false precision in equations and fuzzy concepts in narratives, narrative approaches, talking about, well, like when I was talking about the bats earlier, I said, well, there's a good chance any one of them hits a sequence of events where they don't eat for 3 days, and they're going to die if they don't have a friend to help them. And that's a narrative explanation of what's going on in the bat cave. That's the easiest way to talk about that animal interaction, but it's not mathematically precise. It doesn't have a, you could fit it into this, but you could maybe throw in some observations about if bats don't get helped, how often do they starve to death? But yeah, like you're saying, you've got to do the studies, you've got to get these variables exactly right, or else you can't predict anything. And so that's where the field work comes in.
This is where none of us here is knowledgeable enough to design experiments to test it. We're lay people. I've been studying it intensively for a lot of years, and I'm still a layperson. So, in the end, it's like a lot of other science. Yeah, if you gotta go with something, probably best to go with what the overwhelming majority of biologists think. Yes, Stephen Jay Gould was a group selectionist, and E.O. Wilson was sort of a group selectionist. He was also very much part of the gene selectionist part of biology.
Yeah.
Sociobiology revolutionized a lot of biology.
Yeah, in the back.
Go ahead, I'm sorry.
Yeah, I just want to tell one story. I used to work in the oil fields, and had a lot of time on my hands. And I would stand there in the summers, and I would watch the fish go around the platform. And the platforms are square, they four pilots, but they go around in a circle, swim. And there'll be a shark among them, usually a lemon shark, and it'll just be lazy going around that platform. And then all of a sudden, it'll go and start rolling and biting and thrashing, and it'll just kill everything in its way, these fish. And all the fish will shoot out like the sun rays away from it. And then it'll settle down, and the fish will go around, the shark will go around and just eat pieces of fish. And the other fish will come back in and join that shark and start that circle again. I guess they also enjoy the buffet. And if you wait long enough, and I had time to wait long enough, that shark will do it again. When it gets hungry, it'll tear up those waters.
Yeah, that's,
Yeah, and that was 1980s, and that's where I came away with my idea of evolution.
yeah, those fish have to coexist in a sense with their predator, and maybe staying moving in a school, maybe that's the best way, but if it wasn't the best way, you'd have a problem for the theory of natural selection. You'd have to explain how it would be better off for a fish to go swim off on its own, away from the big attractant that's pulling in these sharks at the school. Apparently they're better off in a school, statistically, numerically, or whatever, than they are off alone. But, when I say that, I'm making an assumption, right? I'm saying, well, the theory must be right, so the observation must fit these parameters. And you don't want to do that, because science is not a dogma. Science is not a religion. We do not presume that the theory of natural selection, even if it is the paradigm of biology, even if it is popular, we don't assume anything is correct, because things that everyone assumed to be the case those assumptions have repeatedly fallen in the past. Why this debate over multi-level selection versus a strictly gene-centered view, like I said, I come away from it thinking this is a Rorschach test, that it tells what sort of inconsistencies you are most uncomfortable with. Are you uncomfortable with potential false precision and potential vague variables, or are you most uncomfortable with these fuzzy narrative stories about how things must work? And that tells more about you maybe than about the field. But anyways, if you're interested in more, I strongly encourage you to read The Selfish Gene by Richard Dawkins. That was published in '76. Also, for the opposite side, read this, Unto Others by Elliot Sobert and David Sloan Wilson. This is a collaboration between actually a philosopher and a biologist. And it summarizes, I think, they're making a case for multi-level selection, but I think they do a fair job of summarizing the challenges on both sides before they make their case. So, highly recommended. This was published in '98, so it still lacks a lot of the information that we have today about, prenatal exposures, epigenetics, horizontal gene transfer, all sorts of stuff like that is not included in this yet, because it's what they didn't know, just like Darwin wasn't able to include what Darwin didn't know. So happy 215th birthday to you, Charles Darwin. I wish you could be with us today, but you're 215 years old. So.
There's no mention of punctuated equilibrium. I guess when Google died.